Okay, so we will be doing logarithms. So just to get into it, you're going to be seeing log with its base. Usually logs have a base of 10. So if you just see like log by itself, there's a base of 10. If it doesn't, it will tell you what the base is. It could be a different number like 2 or 3 or 5. The argument is what's here. So if you see something like log 13 or something, this is the argument. And then they're always equal to the exponent if they have an equal sign. These can be rewritten in exponential form. So this is the base, this is the exponent, and this is what it's equal to. So we're going to be first evaluating logarithmic equations, which are super easy. Basically, a lot of times when solving these or doing these, you're just rewriting them. So this is basically 8 to the what power gets you 1? Well, anything to the 0 power is 1. This one is basically 2 to the what power is 8? Well, 2 to the 3rd power is 8. 8 to the what power gets me 512? 3rd power. 10 to the what power gets me 1 million? 1, 2, 3, 4, 5, 6. 6 zeros. And these are a little more advanced. These will involve fractions and things. So this is going to be to the negative 3rd. Wait, oh, that's 25. Sorry, that's 25. 25 to the what power gets me 125? Okay, well, let's see. So these are a little trickier. So if I were to do the cubed root of 125, I would get 5, right? Yeah, 5. And so then put that in exponential form. 25 to the power of 5/3. Or maybe I should do 3/5. Sometimes you got to play around with these fraction ones. These are a pain until you get better at them. Let's check how they did this one. I know there's going to be, it's not going to be to the power of -3. Maybe it's my calculator being a pain. Okay. Okay, so 25 is the power. Notice that the square root of 25 is 5, which is what I was kind of getting at a little bit. But I did 125. So the square root of 25 is 5. 5 to the negative 3rd is, okay, I get it. Okay, so the square root of 25 is 5. The square root of 25 is 2, right? And then 5 to the what power gets you 125? 3. And then it's going to be a negative since it's in a fraction. So it's going to be -3/2. So you could have like played around with your calculator. If you were to put in your calculator 25 to the power of -3/2, you would get 1/25. There we go. Okay, 8 to the what power gets you 2? Let's see. Well, the cubed root of 8 is 2. So there's definitely going to be a 2 there. Can't do the square root of 8. So yeah, 2 to the 3rd power gets me 8. So let's see, 8 to the 1/3. 8 to the 1/3 gets you 2. This one's going to get you -2. And 4 to the gets you 1/2. Might be 4 to the negative 1/2. Let's check. 4 to the negative 1/2 gets you a half. So those are a little more challenging, but same thing. Moving on. So now it wants you to rewrite these. So rewrite the following form in log C. So basically, if you have that 3 on the outside, you're going to multiply. Or is it the exponent? Let me double check. Yeah, it's an exponent, right? So that 3 is just going to apply to this. It basically becomes like log and then 2 to the 3rd power, which is 8. If you ever see something in front, that's how you would rewrite that. So I have the rules here. I uploaded this. If not, just you can take like a screenshot of this or write them down. But these are the exponential laws, which we already know from doing exponents. And these are the logarithmic laws. So when something is being added, you multiply. When something being subtracted, you divide. And if, like I said, if you have something in front of the log, then it's applied as an exponent. And these are other rules that you're not going to see just yet. Maybe not in this unit, not that I can think of off the top of my head. So like I said, when you're adding, you multiply. 3 times 2 is 6. When you're subtracting, you divide. 6 divided by 3 is 2. This gets you 2 to the 2nd power, which is 4. So those are pretty easy. You're just rewriting them. So now this is the change of base rules. So now you can see the bases are changed. It says evaluate the logarithm. Round your answer to the nearest thousands. Well, for these, you can just put them into your calculator if your calculator will change the base. So when I change the basis for radicals, I like to use this calculator here because the scientific one I have does not do it. See here, it will allow you to change the base. Usually, if you have a calculator and you just put in log, the base is automatically 10. So you could do it this way, right? And then the calculator will do it for you. This is round to the nearest thousandth. Nearest thousandth is 0, 14.970. But there's another way to do it without having to, if your calculator doesn't allow you to. So this says evaluating with the calculator. Okay, so first we need to change the basis to 10. So we're basically putting our argument over our base, right? So log, like I said, already has a base of 10. Where'd they get the 25? Okay, there's nothing in front. Okay, so then you could just put that in your calculator. Log 25 divided by, so if we go to the Desmos calculator, because Desmos only just has the log button. So at least I thought, oh, here it is. Log 25 over log 7. And it gets you your answer, which is 1.654. So you can do it that way, whichever way you want to do it. Okay, so these are also doing change of base. For these, I recommend doing it by hand. I have some students, they rely too much on the calculator, and then when it comes to start solving these, they have no idea how to set them up. So do things by hand before you do calculator. So we have log, okay, so I'm gonna write the top as log m. So argument over base, right? So now I change the base, change of base rules. These both have a base of 10. So now I'm dividing by log m, which is just going to be log m over 1. So argument over 1. And then rules of fractions. When you're dividing fractions, you flip the second fraction and you multiply. Flip and multiply. These cancel out, and then you have 1 over log 9, which is this one. Okay, let's try this one. So we have 1 divided with log 4 over log b. So we're going to take the second one, flip it, and multiply. which just gets us log b over log 4, right? So if we flipped it, let me change color. So you've always flipped the second one. Flip it and multiply. This basically gets me log b over 4. So now b is my argument and 4 is my base. So it would then be this one. Okay, same thing here. 1 divided by log m over log 3. So you're going to flip it and multiply. So then 3, it becomes the argument and m the base. And now we are multiplying. So argument over base times argument over base. These cancel out. This gets you log 18 over 3. No, do not divide them. So let me put in my calculator. Hold on. Log 18 divided by log 3. Yeah, don't divide it. Just leave it like this. Argument base. So that's how you do those. So just practice that first part of the unit first before we get into solving these. You have to know how to rewrite stuff in order to solve, or you're going to have a very challenging time. So practice the first 3, 4, 5, 6 quizzes. The last 3 do not worry about just yet. I also have worksheets to go with solving these. So if you have any questions on the first part of the unit, let me know. Good luck.